Hello and welcome to the 12th part of a series of videos aimed at developing retro games in vanilla JavaScript using the canvas element. My name is Anthony and please join me in my corner of the web where I'm currently building a Street Fighter game within the browser using the latest technologies. As it stands today, our Street Fighter game now has all the fundamentals in place to take it to the next stage, except it's missing one critical thing: sound. When it comes to playing sound on the web, until recently, it has been somewhat challenging. From the prospect of your browser not supporting it natively at all, to which formats of audio you could actually use when it would. Thankfully this has all changed with the introduction of the official Web Audio API. This provides a powerful set of standardized features to allow web developers to finally have control over how their browsers played back audio. As you can probably expect, this is great for game developers who want to create games on the web. With our dreaded to-do list scrolling past, we can clearly see the remaining items are now finally shrinking. But tackling audio will be the main topic of today's video, if you haven't already guessed. We'll first understand where we can obtain the necessary music and sound files, and then explore the options we have to load and play them within the browser and our game. We'll discover what issues this can cause and how to work through them, which by the end of the video should hopefully give the game even more authenticity. We'll also look into finally getting the fighters to react to the attacks by applying their hurt states. This comes with its own challenges though, as you'll soon find out, as this state has multiple states of its own. Namely, as we'll look to make the fighters freeze, shake and then slide away as collision feedback. This should definitely give the attacks more impact, just like the original game. And just before we move on, I'd like to take this opportunity to do a little self-promotion. If I could kindly ask people to click the like button, that would be much appreciated, especially if you find these videos helpful. The majority of people who watch these videos neither do nor subscribe, so it's definitely recognised when someone goes out of their way to do so. Both actions are absolutely free and take minimal effort. It will only help this channel grow and ultimately give me more emphasis to focus and improve on its content, so it's a win-win for everyone. For those who have already done so, either on this video or on any of the others, a big thank you goes out to you. Okay, enough talk, let's get on with today's video content. We'll start by jumping right into the main subject matter of today's video, exploring the idea of adding audio to our Street Fighter game. As mentioned in the previous video, I think we're in a perfect position to do so now, as we have a number of places in the game where we could be playing sound effects or background music. Audio tends to be one of the last things developers think about when it comes to building their own personal gaming projects, and as we're on part 12 of this series, it seems I'm following that trend too. Playing sound on the web has generally had a troublesome past, mainly in terms of how the web works. Some of you might even remember the time where you had to resort to using Flash just to get consistency across browsers. Although thankfully, we've progressed in recent years and playing back audio on the web has become standardised and somewhat improved with the introduction of the Web Audio API. I had originally planned to delve into a subset of this called the audio context, which in actual fact is a vast topic and I'd rather save that for another day and its own video. Instead, we'll use a much easier and honestly less troublesome approach for this series. Similar to how we're loading the images through the HTML file using IMG elements, we'll load our music and sound files there too in a similar way, but using the audio element instead. Just like IMG elements, audio elements allow us to lean on the browser's natural way of asset loading, without any code overhead. Using this method does mean we give up a little bit of control that the audio context and its API would provide us, but for what we're attempting to do today, hopefully you'll see the benefits of what we're doing here too. Either way, I'm following the KISS principle, if nothing more. Anyway, let's jump into VS Code then, and we'll first create a new root folder called Sounds. As you can expect, this will be the location where we'll be storing all the audio asset files. With this in place, the next step is to actually source some of the Street Fighter audio files. We'll start with the stage background music first, and for this we'll jump over to Kinsider's video game music download site. I'm sure everyone is aware of this great website already, but if not, as you can see from the top of the page, the community has done a wonderful job of archiving thousands of video game soundtracks across multiple platforms. But before we lose ourselves with its mounting of archived music files, let's click inside the search box and find one specific entry for our game. Typing Street Fighter Definitive into the box and pressing enter, it should eventually return one album, as shown here. Upon clicking the album entry, it should then list all the tracks available, which you can freely play, which as you can see includes all the stage music for both the CPS1 and CPS2 revisions of Street Fighter 2. Nice! As much as I'd like to get them all, we'll obviously just need the chem theme for our game, at least for now. I'll be downloading the CPS1 version as I'm looking for the original track, but go ahead and choose whatever version takes your fancy. The site usually offers you two formats of the track to download, but as we're making a game for the web, will just take the MP3 version, so go ahead and save that into your new sounds folder within your project. If you can tear yourself away from the site, let's go back to VS Code and see what we've got. In the Explorer sidebar, I'm going to first rename the file to a more web-friendly name. I'll use theme-ken-main.cps1.mp3. I prefix the file with theme to make it more obvious what the file is once it's amongst the other sound files. I've also used CPS1 in the file name, so I can differentiate between the CPS2 version if I decide to get that at a later time. Also, if necessary, you can double click on the file and listen to it within VS Code. Okay, cool, it seems we're good to continue. Let's now open up the index.html file and scroll to the bottom. Underneath the img elements, we'll add our first audio element. We'll give it an ID of theme-ken, which we'll use to identify the audio file, and then add the source path to the MP3 file. So far so good, as this is very similar to the img elements above, although specifically for the audio elements, we'll add a further preload attribute and give it a value of auto. This asks the browser to load the whole sound file into memory. The reason we do this is to ensure the audio is completely available for playback when we request it. Otherwise the browser will manage the file itself and possibly defer the loading to a later time, which might cause the playback to initially stutter depending on the internet bandwidth available. The next attribute we'll add specifically for the stage music is the loop attribute. As you can expect, this tells the browser to loop the audio when it reaches the end of the track, which is exactly what we want for the background music. And to finish off, we'll close the audio tag and save the file. Let's now look to play this audio file back in the game. As this is Ken's stage background music, it makes sense to do this within the Ken stage class. At the top of this code, next to our image property, we'll add a new music property, and just like that one, we'll use the query selector to get the audio data we preloaded in the HTML. If you're familiar with CSS selectors, I'm using a hash and ID name here to specifically get the correct audio element we've just defined. Then in the constructor, we'll simply call the play function on that property, which will cause it to start playing the music as soon as the class is initiated. Pretty straightforward stuff, right? Okay, let's jump over to the browser then and see what the results are from these changes. Strange. For some reason the game isn't playing back the MP3 file, no matter how many times we refresh the page. But why is that? To be fair, we haven't actually done anything wrong. So let's open up the DevTools and see if we can understand what's going on here. Let's first go to the Network tab and ensure it's actually loading the file correctly. We'll do a hard refresh with Shift F5, which will clear the cache, just to be on the safe side. Now, scrolling through the files, we can clearly see the MP3 file has been loaded, or at least partly, with a successful 206 status code, so no issues there. However, notice that we have a couple of unusual messages in the console. These mention that the browser is unable to autoplay the sound because of a permission issue. In fact, as game developers for the web, we've hit one of the biggest hurdles we have today for playing audio. Until recently, I say recently, this was about 5 years ago, you were able to play sound instantly once your web page was ready without any issues. This was great for web games, which are designed to play audio as soon as the game has loaded the necessary assets. The thing is, social sites and advertising teams got wind of this very quickly, and decided to ruin it for us all by auto-playing videos and sound clips in the background whenever you visited their site to gain your attention. This led browsers to applying a stricter policy around auto-playing of audio by default, giving users more control. Which, as a user of the web myself, I agree is great. But unfortunately, as game developers, we now need to accommodate for this change too, because by default, all audio will be muted by default. The full details of this are out of the scope of this video. However, I'll post a link to Chrome's announcement in the description if anyone is interested to read upon this any further. For us though, just be aware that unless we make tweaks to the browser settings, or make our game a PWA, both topics which are out of the scope of this video too, no sound will be played until the page becomes active. This just means you'll either need to click or use the keyboard within the scope of the page first. Let's prove this by jumping back into the browser and clicking anywhere on the game canvas. Then we'll open up the DevTools again. Within the debugger, we'll navigate to the Ken stage class and put a breakpoint anywhere in the update function to stop the game's executing as it updates its entities. Now in the console, we should have access to the music property and its audio data, which as you can see, we indeed do. Okay, let's try playing the MP3 again. And amazingly, it plays just fine. This is because we clicked the browser before we started playing the file. Great stuff. While we're here though, we'll use this opportunity to explore a little of what else we can do with audio files. When the music is currently playing, we'll normally also want to stop it too. We can do this with the pause function, like so. Again, pretty basic stuff. Although one thing to note with this is that the pause function will do just that, meaning if we were to use the play function again, it will now resume the music from where it was paused, rather than from the beginning. If we wish to do that, however, we want to use the current time property. We can use this to either get the current time or position of the audio file, or set it, both of which are in seconds. For example, if we were to log this out to the console, notice how the value increases each time it's called, because the audio is still currently playing. If we were to set this to 0, notice how the audio resets back to the beginning. So if you want to actually stop the music, you'll want to use both the pause function and set the current time property to 0. The last one we'll look at today is the volume property, which basically does what you expect. Either set or get the current volume of the audio file. This property returns a value between 1 and 0, 1 being the default and is the max volume, whereas 0 causes the audio to be muted. One thing I find using music ripped from albums, such as the one we're currently using, is that it's usually too loud. Let's try setting the volume to 0.5 or 50%. There you go, that sounds much better. At least for me and my ears. There's much more you can do with web audio, but with these few settings you'll have the basic control of how your game will sound, and it's enough to cover what we'll be doing today. Back to the issue we have with autoplaying Ken's stage music then, and now knowing we need to activate the page to allow this to happen, let's jump back to VS Code and make the necessary changes. We'll open up a file we've not used since part 2, the index.js file. Either way, we'll simply add a new click event listener inside the current one. This means the browser will now wait until we click the window before the game will start. But this also means it will be activated, and it will be given the permission to play audio. Notice we're setting the once property to be true here, as we'll only ever need this once when the page is loaded. And with all that's been said and done, that's basically it. If we go back to the browser now and refresh the page, we'll be presented with a black screen, as it's now waiting for a mouse click. We would probably want to add a user or a welcome scene here, to explain to the user that they'll need to perform this action to continue. For us, however, we can just simply click through it. And huzzah! We have Ken's stage music playing at the start of the game as expected. This will continue to play and then loop when required. Now that we have this working and have a wider understanding of handling audio files, let's push on and add some of the fine to sound effects next. Just like the music before, the first challenge we need to solve is where would we actually get the required sound effects from. Luckily for us, the Spriters resource has a small sister site called the Sounds resource, which thankfully has exactly what we need. This site works in pretty much the same way as its parent, but instead archiving game sound files. So just as we would with the Spriters resource, we can use the navigation menu on the right hand side of the page to navigate to the Street Fighter 2 page from the arcade option. From here you'll have two options, the sound effects and voices. We'd probably want both of these eventually, but for today we'll just go ahead and choose the sound effects option. The following page will allow you to download a zip file containing the files we need, using an overly large green button. Once that is downloaded, open it up in your favourite zip tool, and you should see a set of 40 WAV files, each presenting a sound effect for the game. However, for now, we'll only need 10 specific files from this list. I've highlighted which 10 files here, but as they're oddly named, I won't waste your time reading them out, but simply copy them over to your sounds folder within your project. Once done, let's head back to VS Code. Hopefully your sounds folder should have the same contents as shown here. These files mostly refer to the attacking sounds for the punch and kicks moves, but at the moment it's not overly clear which is which. So again, before we continue, let's quickly rename the files to a more friendly naming convention. As we work through each file, you should notice that I've grouped and prefixed the names with the strength of the attack first, followed by the corresponding attack type. We also have a land sound, which will be used when the fighters become grounded from a jump. Once eventually completed, we'll now jump back to the HTML file and add audio elements for each of these sounds too, as again this will ensure the browser loads and prepares these for us when the page becomes ready. We'll start with the land sound as that's the only one out, and then move on to the attack strength related sounds. Notice we're giving each of the elements a unique ID name, which is prefixed with Sound Fighter, as this again differentiates between the theme music we previously added. Before we move on, let's not forget to remove the loop attribute from these elements though, as we obviously don't need that for these sound effects. As these new sounds are fighter related, let's open up the fighter class now and add a reference to these there. To make it easier on ourselves, we'll create two new local lookup objects to hold these sounds. One for the attack move sounds, called sound attacks, and one for the actual attack hit sounds, called sound hits. For the attack lookup object, we'll use the corresponding fighter attack strength enum property as the key, and use a standard query selector with the correct ID selector to get the matching sound for each of these values. This makes it easier to reference the correct sound based on the attack strength. We'll do something similar for the hit lookup object too, but we'll need to go one step further and add an extra level for the fighter attack type enum object keys within each of the strength keys. Again, this just makes it easier to reference the correct sound based on which type of attack has made contact. If this doesn't make sense just yet, hopefully it should do shortly when and where we play the sounds back. And lastly, we'll add a sound land property for the remaining sound effect, which we'll quickly use to prove everything is working as expected. In the handle jump land init function, let's call its play function here, as we know this is where the fighter becomes grounded after each jump. Then back in the browser we'll click past the black screen again and perform a jump. Hopefully you can hear that the land sound is actually working as expected, although as previously mentioned, I personally feel the music is a little loud compared to the sound effects. Let's go back to the Ken stage class and use the volume property on its music. In its constructor, just above the music's play function, we'll set its volume to 0.5, or rather 50%. Even though this value is a personal preference, please go ahead and change this as you see fit. Let's quickly check this in the browser again, and to me, while jumping around, the land sound is much more audible, and I'm now thinking it's much more balanced with the stage music. Okay, let's now move on to the attacking sounds. Back in the fighter class, we'll move down to the standard attack init functions. I had originally planned to play the sounds individually in each of these 3 strength functions. Although, now that we have our lookup object, attack sounds, this is no longer required. So let's quickly remove both of the medium and heavy functions and rename the light function to just handle attack init. Then at the bottom, we'll add a call to the play function on the corresponding sound attack, based on the current state's attack strength property. Hopefully you can see how this lookup object has made it easier, if not before, especially how we've now been able to remove code doing so. Nice. But before we move on, let's scroll back up and fix the state machine. For each attack state, we'll replace the current init functions that we've just removed with a reference to the handle attack init function instead. Check in the browser this time, and when we perform each of the attacking moves, the appropriate sound is now played for each of the different strengths of the attack. Not bad at all. Okay, let's move on to the hit sounds next. In the update hitbox collider function, above the current hitbox code, we'll add a play call to the necessary hit sounds enum object property. This time however, we'll use the attack strength and type. So at the top of this function, let's deconstruct these values from the state object first for ease. While we're here, we'll also go ahead and update the next line, with this new variable too. We'll also need to stop, or pause, the attack sound we just played, to stop the sounds overlapping. This will again use the attack strength variable. Checking the browser now, as we perform an attack move that hits the opponent, you'll notice the attack sound is muted as the hit sound is played. Unfortunately, you may notice that some of the sounds when colliding are not necessarily playing as intended. I personally feel we could do better here, so let's jump back into the code and create some of our own sound handling functions. In the engine folder, let's create a new module called Sound Handler. We'll use this file to house any functions that relate to playing sounds. Next, we'll create a new exported function called Play Sound. This will take a sound and volume argument. Sound is the audio we want to play, while volume is obviously the volume in which we want to play at. This will default to 1 for max volume. Now inside the function, we'll check to see if the current sound is currently playing by checking that it's currently not in a pause state, and that the current time value is higher than 0, which we know will be true if it's currently playing. If this is the case, rather than playing the sound again, we'll reset the time back to 0, and therefore resetting its playback. If this isn't the case, we'll simply play the sound as normal. And just for completeness, we'll also add an export to stop sound function too. This combines both the pause function and setting the current time property to 0 to properly reset the sound for the next playback. Okay, let's go back to the classes we've touched today and change them over to use these new functions instead. Starting with the Ken stage class and its constructor, we can now remove both of these lines and combine them with the play sound function, passing on 0.5 as the second parameter. Then in the fighter class, we'll do the same within the update hitbox collider function. We'll replace the play call with the play sound function and the pause call with the stop sound function. And now back in the handle attack init function, we'll repeat this here again too. We'll also perform a little refactor, which will help with resetting the attack sound for the light attacks, as these have specific code to handle quick recession attacks, such as jabs. We'll create a new function called handle light attack reset, which will reset the animation frame as normal, but this time we'll add a call to the handle attack init function, which we know plays the attack sound again. And finally, set the attack struct variable to false, which is actually something we missed in the previous video. We'll then add a call to this new function within both the handle light punch state and handle light kick state functions, replacing the animation frame reset. Let's jump over to the browser now and check to see if these changes have made any difference. As we perform any attacks, specifically the light attacks, they seem to work much better, as we're now checking if the sound is already currently playing. Also, if the attack collides with the opponent, the sounds now seem to play much more fluidly, as we're now resetting the sounds as necessary. Great stuff. I feel at this point I've said the words audio and sound far too much this video, so let's move on to something different, such as getting the fighters to finally correctly react to the attack hits. Let's bring up the original game first, and study what actually happens when an opponent gets hit by an attack. We'll use the light pointer as an example for the moment, but you'll notice there seems to be multiple things happening here. When the attack initially collides, both fighters will become frozen for a total of 15 frames. In this time, the opponent will begin to shake, back and forth. Once this stage is completed, the opponent will then slide back away from their attacker, producing a gap between them. Looking at the shake animation again, for the first 7 frames the opponent's X position is adjusted by 2 pixels, but for the last 8 frames it will only adjust by 1 pixel. Let's take a look at the heavy punch collision now and compare. Most of this sequence plays out exactly the same, but notice how the distance in which the opponent travelled is much further, so it's clear the stronger the strength of the attack, the faster and further they will slide. Another thing to note is that if the opponent touches the edge of the stage boundaries, the sliding force will be transferred to the attacker instead, again leaving a gap between the fighters. So we know the strength of the attack produces a different animation and distance, but where you hit the opponent also makes a difference too. Take these 2 examples here. Notice there's 2 different types of hurt animation, one for the head collision and one for a body collision. They're out of a type of collisions, such as the leg sweep, but those are out of scope of this video series. For us though, this means we have a total of 6 new states to apply to our state machine, 3 animations for the head and another 3 for the body. So back in the code then, we'll first add these 6 new states to the state machine. As per normal, we'll start by adding the necessary keys to the fighter state enum object first. Notice the naming convention here. I prefix them all with hurt, or suffix them with the attack strength to easily identify them. This will become important later. I've also decided from this point to make the value string snake case, so let's quickly update the existing keys to match this new naming convention too. Next, we'll add these new keys to the state machine. It should be noted, even though these states are different hurt states, they are in theory the same state. The only difference to the state machine is that they have different animations. For that reason, they'll all use the same init and update functions and value from lookup arrays, although we'll leave those arrays empty for now and come back to those later. Moving on, we'll now create the init function handle hurt init. This will, like most other init functions, just have a call to the reset velocities function. Then with the update function, handle hurt state, we'll for now just copy the code from the state function above, to allow the hurt animation to play out, resulting in the fighter transitioning back to the idle state when it's completed. Now on to the Ken and Ryu classes, we'll again add the necessary frames and animation sequences to the frames and animations properties. And again, I'm copying these from my prepared code, so as per usual go ahead and freeze the video if you'd like to see the details. One thing to note is the special fighter hurt delay constant we'll be using for the first frame of these animations. This is a special case for these hurt states, which will cover the time the fighter will shake in the game once the attack has collided. We'll look into this a little more soon, but for now, in the fighter constant file, we'll add this new constant at the top of the file. Notice how the value of this constant is a combination of 7 plus 8. This equals the 15 frames we mentioned earlier. Okay, back in the update box collider function, once the attack has struck, we'll now make the opponent transition to the correct hurt state, based on the type and strength of the attack. For this, we'll add a call to a new function called handle attack hit, and pass on the strength and the location of the hit. Although we currently only have this information from the local hurt name array. Let's create this before we continue. We'll remove the current code and jump back to the fighter constant file again, and create a new enum object called fighter hurt box. Just as before, we'll list each of the 3 available hurt boxes. To move forward, we'll now unfortunately have to perform some refactoring again, updating the format of the hurt boxes to use this new object and enum. We'll start back in the update hit box collider function, and for the for loop, we'll update the syntax to use objects entries instead. This illustrates of the new structure of the hurt property in the boxes list, and in turn we'll deconstruct the location and box variables from this, updating the code as necessary. To make this a little more clearer, let's jump up to the boxes property at the top of the class. We'll update the hurt property so that it uses this new structure, using the new fighter hurt box enum as the keys, each with the same default properties. Then in the getBoxes function, we'll again update the code to follow this new object structure too, again using the fighter hurt box enum object as the keys. Lastly, in the debug draw collisions info function, we'll change the for loop for the hurt box to iterate over the values of the hurt property. Okay, with the refactoring complete, let's now get back to adding the new handle attack hit function. We'll do this next to the other handle functions, where it'll take a strength and a hit location parameter. As for this function, its main purpose, at least for now, is just to transition to the correct hurt state as mentioned. For this, we'll create yet another function called getHurtState, which we'll create next to the other get functions. This again will take a strength and a hit location as parameters, and will ultimately return the correct hurt state, based on those arguments. We'll use a switch statement based on the attack strength, and then list each of the keys from the fighter attack strength enum object. For each of these, depending on the hit location, we'll specifically check to see if it's the head or not and return the correctly mapped hurt state. Back to the handle attack hit function. For completeness, we'll go ahead and move the console log message from the update box collider function to this one, although this will probably be best placed inside the fighter debug module, as it's simply a debugging message. So let's quickly do that first, passing on the correct arguments. We'll also update the message to include the strength of the attack too. Now let's call this function inside the handle attack hit function. Nice. And just before we finish, we'll now add the necessary value from arrays to these new hurt states within the state machine. Although these new hurt states all have the same value from array listings. So rather than copy and paste them across all the states, let's create a constant object in the fighter's constant file, as we've done before. We'll call this object hurt state value from, and add the necessary states, which I've again copied from my pre-prepared code. Then back in the fighter class, we'll just replace the empty arrays with this new array constant, and with those changes, you should be done. Let's check the browser again. And thankfully, and even with those little refactors, it seems the fighters are correctly responding to different strengths of attacks, and playing the necessary hurt animation. If we check the console, we'll also too get the updated message log. However, we're also getting some unwanted invalid state change warning messages from the change state function. Let's see how we can quickly fix those two. As we're using an invalid from array lookup list for each of the states to guard against any invalid state changes, we no longer need to compare the current state to the new state, so we can simply remove this line which is causing us the warning messages. If we go back to the browser and start attacking the opponent now, you'll notice the warning messages have now disappeared. The attack should now be a little bit more responsive too, as none of them have been blocked. Great stuff. The only other annoyance at the moment is that Ryu is being drawn behind Ken, due to the entity pecking order they are currently in. Ideally, we'd want the order to be updated with the fighter whose attack connected to be drawn in front of the other fighter. Back to the code we go then. This time in the battle scene class, we'll add a new array called fighter draw order. This will simply be used to hold the draw order of the fighter's player IDs. By default, this will be 0 and 1, which is no different than what we're currently doing at the moment, although we can swap these values around as necessary, depending on which fighter we want to draw first. To make this work, however, we'll scroll down to the draw fighters function and update the for loop to use this new array as a lookup. We'll simply iterate over it and use the values as an index for the fighter we want to draw. Finally, we'll update this array with the handle attack hit function, setting the opponent first and the attacking fighter last, as we want them to be drawn last and therefore on top. And with another check in the browser, this seems to be working pretty well. Whichever fighter attacks, you can clearly see their animation frame, as this fighter is now drawn on top. With all the hurt animations now in place, let's move on to the next stage of the hurt state and make the fighters freeze when the attack collides. Staying in the battle scene class, we'll now add a new local property called hurt timer. Just like any other animation timer, this will be used to hold an amount of time. In this instance, this will be the amount of time we want the fighters to freeze. Inside the handle attack hit function, we'll reset this property to the fighter hurt delay constant we set up earlier, which we know is 15 frames. As it's only a frame value, we'll need to multiply this by the frame time. We'll also need the current game time too, so let's add that to the parameter list for this function. Then within the update fighters function, we'll now simply add a condition to return early if the property is in the future compared to the current game time, meaning it will not update any of the fighters in this period and therefore cause them to freeze. The final step now is to update the update hitbox collider function within the fighter class to pass on the current time object to match the on attack hit changes we just made, not forgetting to add it to the function itself. Let's check the results in the browser, and as you can see, when the attack collides, both fighters will freeze for 15 frames, which matches the first frame in the hurt animation, and then resume once complete. Good stuff, one more stage of the hurt animation is complete. We'll move on to the next stage, which is to make them shake. Staying with the fighter class and at the top, we'll do a quick sort of the current properties, as we'll be looking to add a few more to handle the shaking stage. This will be the hurt shake, to hold the actual adjustment value we want to hold for the fighter's X position, and hurt shake timer, which will be the animation timer between each adjustment. Moving down to the handle hurt init function, we'll set both of these properties with their initial values. Hurt shape will have a value of 2, which you know is the initial adjustment. And while we don't currently have access to the game time object in the init functions, we'll use the performance now function instead for the hurt timer property as a temporary measure. We'll also reset both of these properties within the handle hurt state function too, once the animation has completed. We'll now also add the hurt shape property to the draw function. We do this here as the value is an adjustment, just like the camera, so we don't want it to interfere with the actual X position itself. We'll now add a new function called update hurt shake, which will be used to handle the actual shake adjustment. If either the shake timer is 0, meaning we're currently not in the hurt state, or it's currently behind the current game time, we'll return early from this function, as we don't want it to make any adjustment. Then we'll work out how much adjustment is needed based on the current time and delay. The delay value here is the hurt timer from the battle scene that we just created for the freeze stage. If the delay is less than the fighter hurt delay divided by 2, then we revert to using a 1 pixel adjustment over the default 2 pixel adjustment, replicating the original game's shake variation. Then we'll simply revert the hurt shake property and reset the shake timer for the next cycle. Now back in the battle scene class and the update fighters function, we'll call this new update hurt shake function while the hurt timer is currently in this window, passing on the hurt timer as required. If not, we'll call the standard update function as normal. Let's have another quick check in the browser, and we can clearly see the fighters now shake while they are in the frozen state. I think we can agree, this gives the attack collision more impact. Okay, let's move on to the last stage of the hurt state, and the last thing we'll be adding in today's video, which is the slide. Back in the fighter class, we'll add 2 more new properties, slide velocity and slide friction. These will be used to apply the sliding force to the fighter. Then in the fighter constant file, we'll add a new slide property to the fighter's attack base data object. This will hold the default values for the velocity and friction values we'll apply to the fighter based on the strength of the attack. The values I'm using here are only guesstimates, so I'm not sure how accurate they are, but they will prove the point nonetheless. Notice though the values increase from light to heavy to increase the amount of force that will be applied. And to finish off the initial setup, in the handle attack hit function in the fighter class, we'll deconstruct these values out of the enum object and apply the values to the local slide velocity and slide friction properties. Now we'll create a new function called update slide and add a reference to it in the main update function, passing on the time object. This function will control the slide velocity and attempt to gradually reset it back to 0 based on the current slide friction, meaning the force has come to a halt. We'll start off by checking if the slide velocity is higher or equal to 0, because we know this value should always be a minus value if we're currently in motion. However, if it is, we'll return early. If not, we'll continue and update the velocity based on the friction property. We'll next check if this value is below 0, meaning we still need to apply the force. If not, we'll return out early again. Finally, if it is, we'll finally come to a stop, so we'll reset the slide properties and therefore the slide motion. We'll do this within its own function called reset slide. Let's add this next to the reset velocities function, where we'll just currently set both slide properties back to 0. Next, to apply this force to the fighter, we need to update the fighter's X position with the slide velocity property. Although, let's first extract both position changes to their own function, called update position, to keep this clean and consistent. Now we'll simply add the slide velocity property to the main velocity property on the X position. With another quick check in the browser, and when we attack the opponent now, you'll see they'll slide away as expected, with the necessary force based on the strength of the attack. Nice! One thing that doesn't currently work though is the camera. It doesn't move as the opponent slides into its boundaries, but instead causes them to hit the edge of the screen. We'll look to fix that in the next video, because this actually gives us an easier way to test the next thing we're looking to add today. Transferring the slide motion onto the attacking fighter, if the opponent has hit the edge of the screen. Note, in the original game this would normally only happen at the edges of the stage though. Either way, let's jump back into the code. In the update stage constraints function, we'll add a call to the reset slide function within the screen boundary checks, passing on a value of true. This boolean argument tells the function to pass on the current slide values to the opponent before resetting them. So let's implement that now within the reset slide function, adding a transfer to opponent parameter, which will default to false. As mentioned, we'll simply check if this is true and set the opponent's slide values to the current slide values. And with the last check in the browser today, if we push the opponent to the edge of the screen and now attack them, notice how the slide motion will be transferred from the opponent to the attacker as expected. And with that, we finally have the correct reaction to the standard attacks, now finally complete. Phew, you can probably see why I left this one to last. And for the last thing today, let's finish off as we normally do, with some refactoring. For our first refactor today, I'm going to do something slightly different. As the main topic of this video is sound, let's look to optimize our sound files. Currently they are in the WAV format, which is actually a raw uncompressed audio format, and therefore larger than they need to be. If these were hosted on your personal site, they would take longer to download and could potentially eat through your monthly bandwidth pretty quickly. Let's look to convert them into a more web-friendly format called OGG. For this, I'm going to use a free audio tool called Audacity, which is available for all platforms. I'm not going to go into this tool today, but just know it's an incredible thing to have in your game development toolset. For this though, we'll simply open each sound file, and then re-export them in the OGG format into the sounds folder, alongside the WAV version of the file. While we're here, we might as well convert Ken's theme music too. Here's a quick comparison of the size differences. As you can see, it's pretty huge, so a healthy saving for both you and your users. But back in VS Code, we can safely go ahead and remove the original files, as we no longer need them. We will need to update the HTML file though, so that the file source paths match these new file names. Next on the list is the remove entity function in the battle class. Even though using the filter here is good enough, we'll refactor this to use a splice instead, just for the added speed this provides. Although you could easily skip this one, but thought it best to show you an alternative. We'll now move the focus to the fighter debug file. As we have multiple exports now, let's rename the functions to remove the debug prefix, and instead use an import alias instead. This makes it easier to group the functions together with a custom prefix. Let's make this change in the fighter class and update the references in the handle, attack, hit and draw functions. Next we'll align a couple of constants within the update stage constraints function, as these have been sitting unchanged for a while. First taking the width variable, moving it to the fighter constant file and naming it fighter default width instead. Then with a push friction constant, naming it fighter push friction instead. We'll obviously need to update any references where these were being used before continuing. We'll next update the current state property to actually use the idle state by default. As we've made changes to the state machine since the beginning of the series, we no longer need it to be undefined by default. So let's do that and remove the change state function call from the constructor and the undefined case from the idle valid from array. Always feels good when you can remove code, especially when it results in cleaner code too. While we're in the state machine, let's do a small tidy of the valid from arrays here also. Let's move our focus onto the handle hurt init function and its use of the performance now call. While this was fine in practice, it's not great from a consistency point of view. Ideally we'd want to use the actual time object, so let's make the necessary changes to allow for this. Let's add the time parameter here and set the hurt shake timer to use it, but for this to work we're going to need the time property when the state machine calls the init function. So in the change state function, we'll do the same here, adding the time parameter and also as an argument on the init call. This does mean we'll now also need to update all the change state calls and append the time argument. This will be quite a meaty change, but it's not all bad, as this should only happen in the handle state functions, so we'll highlight those with a find tool within VS Code, and quickly go through the calls, doing just that. Phew, all done. For the last refactor for today, as we now have the time object available in the change state function, let's go ahead and update the update animation function too, to take advantage of it. We'll first cut the current code, as we'll be moving it to its own function, but we'll replace it with a timer check and exit early if no update to the animation is required. Then we'll call a new function called setAnimationFrame. This will be used to handle any animation frame changes from now on. For the update animation function, we'll just need to increase the frame by 1 though, so we'll do that and pass on the time object, as that will be needed too. Let's now create this new function and paste the original code into it, and add the frame and time parameters. We'll now make some minor refactors to the code, so that it falls in line with these new parameters. Frame being the animation frame we want to set, and time is the standard game time object. This function should now be used whenever we want to set the animation frame, as we're now able to encapsulate the time object directly, giving it more precise timing on the initial call. So back in the change state function, we can replace the manual frame set with a call to this function instead, and again in the handle crouch down state, and the handle light attack reset functions. And with those changes complete, let's check the browser for one last time today and see where we are. It would seem we've not broken anything at least, so that's a plus if nothing more. The music and sound is still playing just fine, even after the conversion, and Ryu and Ken are still reacting properly to the attacks with their new hurt states. So with that, let's quickly review what we've achieved today. With sound now in place, the game has become even more faithful to the original. It's a wonder how something as little as the background music can improve this. Although we didn't stop there, We went ahead and added all the sound effects we could to cover the fighter states we currently have implemented too, again improving its authenticity. We also took the necessary action to accommodate the autoplay feature in browsers to allow us to actually play sound back. And finally, we've now added the missing hurt states so that the fighters can react properly to their attack collisions. We also delved into this a little deeper to understand this had multiple states of its own, making it a little more complex than the other states within the state machine. This leaves us in a good position to focus on the more complex moves in part 13, where we'll try to understand special moves such as the infamous Shoryuken, along with their control combinations. It was far easier just to play the sound rather than me trying to pronounce it in my English accent. Depending on time though, we'll also see what other moves we can include too, although this will be my last official video in the series, so who knows how that'll turn out. And there you have it. It seems we have another long video today. I'm still following the trend of increasing the duration of each video with each new part. I've not heard any negativity so far, so hopefully people don't mind this. But yes, if you've not heard at this point, next month's video will be the last official video in the series, at least for now. I'm assuming this video will be the longest one to date too. If nothing more, it'll end on a high. I'm hoping to continue with the Street Fighter code after this however, where I'll no doubt post updates here in the shape of vlogs. I'll then look to change things up a little and possibly start another series of videos, but more news on that soon. Either way, I'll be tempted to keep up the schedule and post at least one video per month, along with keeping the tutorial code coming on YouTube and to my Patreons. While on the topic of support though, just before we close up for today, I'd like to thank everyone who has subscribed, followed and liked any of my content so far. I'm amazed at the time of writing, I'm so near to the 550 subscriber mark now. I honestly would never have thought it was even possible, both on this channel and on my Patreon page. So a big shout out to all my Patreon supporters here. You guys really do spur me on the most. And with that, I'll say my goodbye and hopefully see you in the next one. And out.